Hey chaps, I hope you're all well. It has been a little while since we did some work on the series, and as such, I think it's time to make up for a little bit of lost time and get right back into it with a bit of progress. In today's episode, we're going to be looking at the starting point for collision layers, which we can then use to begin adding some life to our maps. The idea is that we're going to use the collision layer as a means for understanding where things live in our world and what spaces are available for objects to move around in. If you think of it like a board game where the player and other objects living in the world can only move around the board in ways that abide by the rules of the game. Whilst the collision layer is not going to directly house these objects, it's going to serve as an aid for deciding where and how those objects can move around our world. And as such will be used for pathfinding capabilities as well as we move forward. Anyway, enough about that, let's just dive right into it. Okay, so first things first, we're going to head over to the engine project. Go to tile maps, and we're going to right click, add new item, and we're going to create a new class, and I'm going to call this collision layer. Okay, so now we've got our collision layer class. This, much like our tile layer class, is going to accept 4 arguments in its constructor. Those are going to be for the individual cell width and height for each collision cell, and then the width and height of the collision layer in its entirety. So let's create the constructor now. Collision layer, cell width, cell height, width, and height. Alright, now we're going to store those details in the collision layer. So I'm going to have a private int for cell width, a private int for cell height, and then we need the actual cells themselves. So in the tile layer, when we do this, we create a 2D array of tiles, but in our collision layer, we're going to create a 2D array of simple booleans. Okay, that 2D array, all it needs to really represent is whether we can, i.e. true, or cannot, i.e. false, walk onto a cell. So that's why we just need a simple collection of booleans. So I'm going to create a private bool 2D array, and I'm going to call this cells. So in my constructor now, I'm going to create those cells and store our cell width and height. So this cell width, cell height equals cell height, and then I'm going to create my cells. So cells equals new bool, width, height, and that's my cells created. Now when we created our tile layer, if I head over to the tile layer now, you'll remember that we looped through all of the tiles and created instances of new tiles. Now we don't need to do that in the collision layer because a bool is a struct, it's a primitive, so it will therefore have the default value of false for us. So now that we have our collision layer class, the next thing we need to do is add it to our map class. So if we head over to the map class now, in here underneath our list of tile layers, I'm going to create a new variable or property for our collision layer. So public collision layer, I'm going to call this collision layer with a get and private set. For the same reason as we did for the list of tile layers, so that only the map class itself can set this collision layer. I've got an accessibility error there, yep, so back in the collision layer class, let's make this public. Okay, and back in the map class it should go away, yep. So the way I want this to work is I want a map to always have a collision layer present. So that's why we have this property of its own here, it's separate to the list of layers. So in our constructor for the map, we're going to create an instance of that collision layer. So collision layer equals new collision layer. And the cell width and height can be whatever you want it to be really, but for the sake of simplicity, I'm going to make it match up with the size of the tiles as well. So for now, I'm just going to make this tile width, tile height, and then width and height. Okay, so that's our collision layer instance. And so the next natural step is to start visualizing our collision layer data. And to do that, we need to add some draw functionality to our collision layer. So over in our collision layer class, we're going to add a new draw method for our collision layer. So we're going to create a public void draw, and this is going to be passed a sprite batch. Call that sprite batch, press enter. And then we also want to be passed a camera vector2. Camera. Control period on vector2 using Microsoft XNA framework. And in our draw method now, we need to start iterating over our cells and drawing their visual representation of whether they can or cannot be walked onto. Okay, so much like our tile layer drawing functionality, we need to iterate through the X and the Y. So for int X equals 0, X under cells dot get length 0, X plus plus, Y equals 0, Y under cells get length 1, Y plus plus, and then we start drawing each individual cell. Okay, so first we need to calculate the cell position, where it's going to be drawn in the world. So the cell position is equal to new vector 2, X multiplied by cell width, and Y multiplied by cell height. And then we need to work out whether this cell is walkable or not, i.e. is the Boolean true or false. So walkable is equal to cells X, Y. Okay, and then we need to start drawing the visualization of whether it's walkable or not. So first of all, we're going to do if it is walkable, then we're going to call sprite batch fill rectangle cell position new size 2 cell width cell height, and then if it is walkable, we want it to be a nice shade of green, so we're going to take the color green and we're going to half it. So we don't want a full opaque green, we want a half transparent green. Okay, so that's if it is walkable. If it's not walkable, then we want a similar process. If I'm just going to copy this line and paste that here, I'm going to make this red. In essence, we could change this around a little bit, so if it's walkable, we just set a color. If not, we just set it to red and then use this same code in one place. But it's fine as it is, not really causing any drama, so we'll just roll with that for now. And then lastly, we want to draw a square around the cell so we get that grid effect, okay? Much like we do for the tiles. So sprite batch, draw rectangle, and this is going to be the cell position again. And the size is going to be cell width, cell height, and the color for this one is just going to be white. Okay, so there's a few places there where we're just kind of copy and pasting code around that we could just reuse, and feel free to do that, but for the sake of this, just the simplicity, I'm just going to keep it like this for now. Okay, so that is drawing our collision layer data. Next, we need to actually call this method from the map class. So head over to the map class, and where we draw our map here, I'm going to draw this in between where we draw the layers and then the immediate tiles. So we'll draw it here. So we're going to take our collision layer, and then we're going to draw, pass in the sprite batch, and also pass in our camera. Okay, so for the first time in a while, we're going to crank up our editor and see what that looks like. So I'm going to hit start now. Okay, and you'll see we've got a nice plane of red just covering our entire map. And that's because all of our cells are not walkable, because it defaults to false for each of the cells. And of course, we're not toggling whether it does or does not draw the collision layer either, so it's always going to be there. So that's another feature we're going to add as well, so we can turn it on and off. So let's close down the editor now. Okay, so the next thing we're going to look at and focus on is actually toggling the visibility of our collision layer. And so first of all, to do that, we need to add a property to the collision layer to represent its visibility. So if we go to the collision layer class, at the top of the class, we're going to add a new public property, public bool visible, and this is going to have a get and a set. And then of course, we only want to draw the collision layer when this is true. So in our draw method here, we're going to go if it's not visible, then we're going to return out. Okay, so now we've got our property to represent our collision visibility, and with this turned off, it will no longer draw the collision layer. The next thing we need to do is add a checkbox to the editor to actually toggle the visibility of this collision layer. So over in the editor project, I'm going to right click on form 1 and view designer. And here I'm going to open up the toolbox. I'm going to find checkbox. let's go to all Windows Forms, drag in a checkbox, pop that underneath our layers list there. I'm going to give this some reasonable properties. So the checkbox, I'm going to change this to the text. I'm going to change this to toggle collision layer. Okay, and then the name, scroll down. I'm going to change this to check collision layer visibility or visible. Okay, so what we want to happen now is when we change the value of this checkbox, it will change the visibility of the collision layer. So to do that, I'm going to click on our collision layer checkbox here again. Click the lightning bolt for events. I'm going to find the checked changed event and double click in the editor space here. What this does, it will create our event handler for the checked change event, which will fire when the checked value of that checkbox changes. Okay? And what we're going to do here is change the value of the collision layer visibility when the checked value changes. But first of all, we need to go to our MonoGame editor class. Right click on him, right click view code. And in here, what we're going to do is we're going to add a method essentially which will delegate down to setting the collision layer's visibility. So where I'm going to put this, I'm going to put this underneath load map before our update. I'm going to let public void set collision layer visibility or visible, doesn't really matter. Let's go visible and bool visible. What this is going to do is going to take the map, my map, and then the collision layer, and then set visible to whatever value is being passed in to this method. Okay, with that done, let's go back to form1cs, and then in here, what we're going to do is just pass down the value of the checkbox to that method. So I'm going to get MonoGame editor 1, set collision layer visibility, or visible, check collision layer visible dot checked. Okay, so as the checkbox value changes, we're going to pass that down to that method, which will set the visible flag on the collision layer. Let's give that a quick run just to see if it works. Hit the start button. Okay, so now I've got our checkbox here, and you'll see straight away that the visibility of the collision layer, you can see that it's not there. So clicking the checkbox will make it visible, and then unchecking it will make it no longer visible. There is, however, one existing problem that we need to solve as well, and that is the visibility flag on the collision layer may fall out of sync with the checkbox value. And what do I mean by that? Well, because the default value of the collision layer visibility is false, if we leave that checkbox checked and then create a new map, the checkbox will appear checked, but the visibility of the collision layer will still be false. So if I hit start, I'm going to set the visibility of my collision layer to true. Then I'm going to create a new map, 32, 32, 32. And you'll see there the checkbox is in fact checked, but I cannot see my collision layer. Okay, so if I close down the editor, there's one more thing we need to do here, and that is we need to take this line of code, and we also need to call it when we're creating a new map. Okay, so here, where the new map event is fired and we handle it, we just want to call that same code. Okay, so if I hit start now, I'm going to set my visibility to true on the collision layer, and then I'm going to create a new map, 32, 32, 32, 32, and you'll see the visibility has persisted to my new map. Now there would be the same problem when loading an existing map as well, but because we haven't considered that as a use case yet, we'll come back to that soon. So let's close down the editor. And now we're going to take a look at the concept of changing the values of each individual collision cell on the layer. And to do that, we're going to introduce the concept of different paint modes. If you can imagine now, we paint tiles, but we want to introduce an additional paint mode where we can also paint collision tiles as well, or cells. Okay, so we're going to open up Form 1 Designer, right click View Designer. Okay, so we're going to shuffle this around a little bit to make some room for our different paint modes. And we're going to do that with radio buttons. So I'm going to select all of my controls here and drag them down a little bit. Just about there. Might stretch my window out a little bit more to make some more room. Select them all again, drag down. Okay, so what we're first going to do is open up the toolbox, and we're going to add a group box. Drag that in, position that over the top here, stretch that out. Okay, and in this group box is going to house our radio buttons, and the way the group box is working for us here is that it is providing a group for those radio actions. So all the radio buttons in here are within one radio group. What that means is only one of them in this box can be checked at one time. So selecting my group box, I'm going to go to the properties. I'm going to set the text to paint mode. So in here, I'm going to put my two radio buttons representing the two different paint modes. So I'm going to open up the toolbox. I'm going to find a radio button, drop one of those in there, and then we're going to copy and paste for another one and drag that underneath. Move them down a little bit. Position this however you like. Okay, so I'm going to move everything back up now that I've got it in place, about there. Okay, so my two radio buttons. So the first one, I'm going to select that. I'm going to change the text of this radio button to be paint tiles. I'm going to change the name to radio paint tiles. I'm going to repeat for radio button 2, but instead of radio paint tiles, it's going to be radio paint collision. Change the text as well. Okay, and we want the default value to be painting tiles too. So we'll select paint tiles and then we'll find the checked value. Should be in here somewhere, hopefully. There it is. We'll set that to true. Okay, let's give that a run and you'll see how that works. Obviously, no logic has been performed on them just yet, but it'll show you how they are grouped together. So if I select collision, it'll check paint tiles, and conversely, when I select paint tiles, it'll uncheck paint collision. Okay. And so next, the thing we want to do is let our editor know what paint mode it's in. And to do that, I'm going to go to the MonoGame editor, right-click View Code, and at the bottom of this class, I'm going to add an Enum. Okay, so public Enum paint mode, and this is going to have two modes in it. So tiles 0 and collision 1. And then of course we want our current mode. So at the top, underneath our active layer, I'm going to add a public paint mode. So that's going to house our current mode. Okie dokie. So next what we want to do is handle the values of those radio buttons changing to then set the value of this mode. So in our Form 1 designer, I'm going to select paint tiles. And then, much like a checkbox, these have the same event called the check changed event. So if I select the lightning bolt for our first radio button, double click in the editor space here for check changed, and then we go back and repeat the process for paint collision. So now I've got our two event handlers here. So in the first one, for paint tiles, I'm going to check if radio paint tiles is checked, to which if it is, I'm going to get the MonoGame editor 1 and set the mode to paint mode.tiles. And then in the collision event handler, I'm going to do the same again, but set it to collision. So now what we're doing is we're now setting the paint mode that our editor is in to the appropriate mode represented by the radio button. Oh, and I've just noticed there I haven't changed this to radio paint collision. Okay. So the next thing we need to do is update the logic in our MonoGame editor control to start honouring this new mode that we've added, that is the collision paint mode. And also only paint tiles when we're in the correct mode for painting tiles. So if I head over to the MonoGame editor CS file, scroll down to the update method, and find the logic where we paint tiles whilst the left mouse button is pressed here, we need to update this logic to only paint the tile if the mode is in fact paint tiles mode. So in this condition here, where we check that the tile is not null and the brush is not null, we're also going to check to make sure the correct mode is in place. So if mode is equal to paint mode, tiles, and then use the original conditions. Let's give that a quick test to make sure that worked. Oh, we've got a build error. Oh, I forgot to put an equals on my enum there. Okay. Scroll back up. Right, so we hit start now. And then I'm in paint tiles mode, so I can select a tile set, select a tile, paint that all day. And then if I change this to paint collision, I shouldn't be able to paint tiles, which I can. Okay, so that's all working as expected. So the next question is, how do we update the collision layer like we do the tile layer? Now obviously the collision layer is a little bit different to the tile layer because the tile layer returns tiles and the collision layer is only going to return bools. So it will work a little bit differently, however the premise will remain the same in that we return a tile position detail, we'll then return a cell position detail, and we'll change the properties based on the result of that. So what we're going to do is going to go to the tile layer class, and we're going to take the existing method for the tile layer, get tile at position, and the tile position detail class and make a cell position detail class in the collision layer. So scrolling down to the bottom of here, we're going to take the public class tile position detail, copy that, paste that into the collision layer class at the bottom, and change this around ever so slightly for our new use case. So I'm going to change this to cell position detail. I'm going to remove tile because that's not going to be needed. But then at the bottom, I'm also going to add a bool for is walkable. Get set. Okay? Because for each cell, it will either be walkable or it will not be walkable. Okay, so next from the tile layer class, I'm going to take the get tile at position method here, copy that, paste that into the collision layer, just above our draw method here. I'm going to change this around for our new cell layer or cell position detail on our collision layer. So here I'm going to change this to cell position detail, change the method name to get cell at position, copy that over these ones here. Tile width becomes cell width, tile height becomes cell height, tiles become cells, and then detail.tile here, this now just becomes detail.is walkable equals cells xy. Okay, and that's pretty much it for that method. Now, of course, when we're getting this information from a tile layer, we go through the map. So going to the map class, we have this entry point here for get tile at position, and then we pass a layer index into it, which then works out which layer to get the tile position from. Now, this will pretty much be a simple method to pass straight through to the collision layer, but I'm going to add one here anyway, just for consistency. So I'm going to take this, paste it underneath. I'm going to change it to cell or collision layer dot cell position detail, and we're going to change this to get cell at position. Obviously, we don't need a layer index, and the return value of this is going to be return collision layer dot get cell at position, and then we don't need any of these layer index checks. So it's a fairly straightforward method, but for consistency's sake, like we have one for get tile at position, I'm going to provide one for get cell at position as well. And it's also this method that we're going to use in the MonoGame editor class to pull out that cell position detail. So if we head over to our MonoGame editor class, scroll up to where we get the tile position detail, we're going to do something very similar, but for the cell position detail. So I'm going to copy and paste that line, collision layer dot cell position detail, and then this becomes cell position detail equals my map, get cell at position, and then we don't need to pass in the layer anymore. Okay, so now we're going to use this cell position detail to change the collision layer data, or each individual cell, as we decide to paint over it. So if we scroll down now to where we have our mode for painting tiles, we now need to do another check to paint differently when we are painting collision. So here I'm going to go for else if mode equals paint mode dot collision, and our cell position detail is a valid position. Okay. Then we're going to change the cells on the collision layer. So as I said previously, this is going to work a little bit differently to the tile layer, because in the case of the tile layer, we are pulling out the tile references, the direct references to the tiles, because they are a class, and then we're changing the details of that tile here. And that change is reflected on the tile layer. In the case of the cell position detail, which returns as simply a true or false, we cannot do that. So we need a different method of updating the collision layer. So to do that, I'm going to go to the collision layer class. I'm going to add a new method under the constructor here, public void, and then in here I'm going to make this update cell, and this is just going to take, what can this take? This will take a bool for whether it's walkable, and then x and a y. And then all I want to do here is update the values of the cell based on this boolean. So cells x, y equals walkable. So all I'm doing is saying true or false, whether it's walkable, and setting this cell at that x and y position to that value. So back in our editor class now, what we can do here is we can update the logic for our block of code here to then change the values of the cells as we go. Now when we come into this block of code, it's a given that the button for the left mouse is pressed. I want to change the behavior here slightly to work a bit differently around painting collision cells. Because we're toggling something on and off, it's a little bit different to painting tiles. If you turn something on and off quick enough, repeatedly, you won't see the change, or you might see a quick flicker here and there, so it's not really desirable behavior. To get around this, what I'm going to do is introduce some additional functionality, whereby if you hold down the control key on the keyboard as you click and drag, it'll make a collision cell not walkable, and if you're not holding the control key, it will make it walkable. So to do that, we need to introduce the keyboard state. If we scroll up to where we get the mouse state, underneath where we get the mouse state, we're going to set a new variable for keyboard state extended. Keyboard state equals keyboard extended dot get state. And then we just need to make use of that keyboard state in our conditional block down here for painting the collision. So what I want to do is, if you're holding the control key, so if keyboard state is control down, I want to then set the cell that we're hovering over to be collidable, so not walkable. So my map, collision layer, update cell, I'm going to pass this false, and then I'm just going to get the position from the cell position detail that we got previously. So cell position detail dot coordinates dot x, cell position detail dot coordinates dot y. Okay, and then conversely, when you're not holding the control key, I want to make something walkable. So collision layer, update cell, true, cell position detail coordinates dot x, cell position detail dot coordinates dot y. Okay. Now let's give that a quick run through to make sure that works as expected. Let's hit the start key. Okay, so we're not seeing our collision layer here, so we've got it toggled off. If we toggle it on, I'm in paint tile mode, nothing happens. I can paint a couple of tiles here, so you can just see them underneath the red. If I switch to paint collision mode, you'll see it still shows the tile. We can change that later on if necessary. But if I just click and drag now, you'll see it makes them green. If I hold down the control key on my keyboard, click and drag again, you'll see it makes them red once more. So now we're actually able to paint collision data onto our collision layer. So last but not least, we have to actually save and reload this data when we save our tile map. Okay, so we've done that already for our tile layers. It's a very simple process to then copy that over and do the same thing for our collision layer. If we head over to our tile layer class, we'll see we have an additional constructor here which calls through to load, so we'll copy that first of all, head to our collision layer class, paint that under our existing constructor, change it to collision layer obviously, add an appropriate using statement for binary reader, control period, using system IO. Obviously load does not exist yet, we'll soon be adding that. And then over in the tile layer class, if we scroll down to where we have our save and load methods, we're going to copy both of those, save and load, and we're going to paste that into our collision layer and just change it around a little bit so it makes more sense for this use case. So above our cell position detail class, I'm going to paste in those methods and change them around appropriately. So when we're saving, we want to save the cell width instead of tile width even, and then we want to save the cell height instead of the tile height. We don't have a name, but in place of tiles here, so this is saving the size, so the width and height of the layer in its entirety. So cells get length 0, cells get length 1. And then of course we want to save the Boolean value of each individual cell, much like we did here for saving the tile set and tile indexes for the tiles. So change tiles for cells. And then here all I want to do is write cells xy. So that's a Boolean on its own. Okay. So now I have to do the inverse on the load. So when we're loading up, the first thing we've written was the cell width. So that's the first one we need to read back. So cell width, reader reading 32, cell height. We didn't write a name. We have a width and height, that's correct. We then need to instantiate the cells. So cells equals new bool using that width and height. And then we want to take that cell size, much like we did for writing, we do the same thing reading back because we created the cell array here, so we have the width and height already. And then we just set the value based on the Boolean we've written to the file. So cells xy equals reader read Boolean. Okay, so that's it for the collision layer saving and loading. We actually now need to invoke that from the map itself. Okay. So if we go to the map class, what we're going to do now is we're going to find our save and load functionality for the map class. So here, so underneath where we save the layers, I'm now going to save my collision layer, save, pass in the stream, and then same thing for load, where here we create a new tile layer and pass in the reader. We're going to create a new collision layer and pass in the reader. That is the second constructor we've just created. Okay, so let's give that a quick run through. Over in here, I need to pass writer, not stream. I apologise. There we go. Let's give that a start. Oh, got an error. I left a tile in there. Whoops. Okay, now let's give it a start. Okay, so we've got our map here just for sanity. I'm going to create a new one. 32 by 32, 32, 32. So we've got quite a big map. I'll zoom it out. Let's first of all paint some tiles to make sure that's working. So we'll paint some tiles. Okay. And now let's paint some collision data. So we can't see our collision layer, so let's make it visible. And let's paint in some green squares as well. Okay, let's give that a save. Test map. Let's create a new one. So I'll make this 10, 10, 10, 10. Okay, and then we're going to load in our other one. So load test map. So there is our map loaded up with its saved collision data, and if we turn the collision layer off, there is our tile layer data as well. And that's a wrap. So I hope you enjoyed today's episode, guys, adding collision layers to our MonoGame RPG. Moving forward in the next episode or two, I want to start looking at adding some actual interactive behavior to our game, so we can start launching up a previewer, so we can start walking around our maps, actually explore our creations a little bit more, and start adding some interactivity to our games, really. So I look forward to that one. I hope you've enjoyed today's episode. Please hit subscribe, hit that notification button, and I will speak to you soon. Cheerio, chaps.